Okay, a couple examples here from 2.5, okay, similar to the homework problems. Let's see, whoops, there we go. Okay, so these problems use the generalized power rule, and I've written it here in one of the similar versions to what you'll see in the book. Generalized power rule we use to take the derivative of a function to a power. Now, the power rule is for the variable to a power, but if it's something more complicated raised to a power, then we have to use this rule. Okay, and it's very similar to the power rule, but it does have one big difference. If you're taking the derivative of a big function to a power, okay, the power is just some number, you bring the power down, decrease it by 1, but then you have to multiply by the derivative of that function that you were raising to a power. Okay, so let's look at one of these. Okay, so here's a problem similar to number 7 in 2.5. But here's what we have to do. Okay, they ask us to find y prime, which is just another way of saying the derivative. Okay, so we have to find the derivative with respect to x of 5 over the square root of x plus 7. Okay, now you're always trying to reduce the amount of work you have to do, and this is one where you might have to do a couple of things to rewrite it. Okay, first of all, the square root of something is the power 1/2. So this is 5 over the power over x plus 7 to the power 1/2. But having that power in the denominator makes you think of the quotient rule. Well, we can actually write this as not just 5 over x plus 7 to the 1/2. Let's do it this way. Okay, we can actually make that power, bring this term into the numerator by flipping the sign of the power. Okay, and that's important too. So we're taking the derivative of 5 times x plus 7 to the negative 1/2. Okay, so now the power rule seems to make sense. We've got a function raised to a power here. Okay, and that's always the first step before you use the power rule. You need a function raised to a power. Okay, so to finish this one, I'll go over here to give myself some space. First of all, that 5 is no big deal. We need to factor it out. Okay, but then I'm going to take the derivative of what's left over, x plus 7 to the power negative 1/2. Okay, and if you look at the power rule, it says this: you bring the power down, okay, decrease it by 1, so the new power is going to be negative 3/2. That's a half minus 1. Okay, but then you have to multiply by the derivative of what's inside. Okay, if this is a complicated function, the derivative of what's inside that power expression could be complicated too. Now in this one, the derivative of x plus 7 turns out to just be 1. Okay, so, whoops, and I forgot one thing. There's this 5 I also need to be multiplying here. Okay, so I'll tuck that in here. So what do I got? Well, I have the 5 times the derivative that I had to compute using the generalized power rule. Okay, so here's what I've got. I can simplify it now. If I bring together all these constants, I'm just going to get negative 5/2 times x plus 7 to the power negative 3/2, which, you know, you can probably write that way. You can also write it as negative 5 over 2 times x plus 7 to the 3/2 power, okay, which in turn is going to be negative 5 over 2 times the square root of x plus 7 cubed. And WebAssign should probably accept all of these, but this one's certainly okay, and this one, you know, would be probably good too. Either of these it should accept. I would imagine if there's a preference it's the last one, but typically we don't like to leave powers negative in a final answer. So anyway, those are okay. Okay.